to last correct topics over scientific notation, and it's something that if you've taken a science class, you've probably seen where it's times 10 to a high power, it means it's just a really large number. And if it's times 10 to a negative power, it's a really, really small number, and it's a way to concisely write like big and small numbers. So like, I'm trying to think, is it chemistry when you're talking about molecules and Avogadro's number, that kind of thing? Why I have a correct topic on it in here is because when we start chapter 5, when we're finding some of these probabilities, some of them are really small, and your calculator actually gives you the answer in scientific notation, which doesn't look quite like what you're used to, first of all. And secondly, even though your calculator gives it to you in scientific notation, my math lab does not want you to write it like that. They want you to use 0.00081 or something like that. So we have to be able to go back and forth between the two. So before we get too far, we're going to write like this table up here. This table is going to have 2 rows. So we'll just put a line kind of right down the middle, guys. And we have to do, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to do 8 vertical slashes. 1, 2, 3, 4, 5, 6, 7, 8, like that, okay? And we're going to fill out this table. So right in the middle, 1, 2, 3, 4, 5, we're going to represent the number 1. And what it is none of you guys are going into teaching, are you? Okay, if you took a math for elementary teacher class, you actually talk about different bases. Our number system's base 10, right? Once we get 10, we go on to the next place value, and we have 10. So once we get to 10 tens, we go on to the next place value, we have 100 and so forth. So you can actually talk about different bases. Anybody into computer programming, base 2, all they use is zeros and ones to represent their numbers, okay? So how do we represent 1 as our power of 10? Well, remember, any number to the 0 power is actually the number 1, okay? So that's kind of our middle guy. So 1 is actually 10 to the 0 power. Let's go to the left first, okay? No, let's go to the right first. So we'll do 10. How do we write 10 as the power of 10? That's just 10 to the what power? The first, right? So I'm just going to change my powers. How do you write 100 as the power of 10? 10 what? 10 to what power?
Second.
The second, right? 10 squared is 100. You see what we're doing? So we're just taking 10 times to itself once, 10 times itself twice. So what's the 1,000 going to be, guys?
10 to the third.
10 to the third. And what's 10,000 going to be? 10 to the fourth, and so forth. Okay? I probably went backwards. I have this flip-flop. That's okay. It won't really make a difference. Okay. Then, if we want to do a tenth, this is something that's kind of interesting that we don't realize, is that negative exponents mean a fraction, okay? So a tenth is 10 to the negative first power, meaning you take this to its first power, so 10 to the first is 10, but then you put it in the denominator, so 1/10. So then 100th is 10 to the negative second, and so forth, okay? 1,000th is 10 to the negative third, and 10 thousandths is 10 to the negative fourth. Again, we don't have to have these memorized. I'm just showing you that any number, whether it's in the ones, tens, hundreds, or tens, hundreds, thousandths, decimal or whole number, we can write it as a power of 10. And that's the whole idea of scientific notation. So how scientific notation works is that the front number that you're multiplying by times 10 to whatever power must be a single value between 1 and 9 included, okay? So that means we need to move our decimal and so that we have one value in front of it, all right? So with this, you guys see the number 582, but what we're going to do is we're going to move the decimal so that it's behind the 5, so only one value is in front of our decimal. So we're going to go 1, 2, 3, 4. So we have 5.82 times 10 to what power? Well, however many spaces you had to move it is the power that you're going to have for your 10. Just remember, really, really small numbers are represented with negative powers, and really, really big numbers are represented with small or positive powers. So since this is a small number, you guys agree that 0.000582 is a really small decimal. This is 5.82 to the negative 4. Number 2, guys, we're going to do the same thing. We're going to move that little decimal until it's behind what number? The 1, right? Because we just want a single digit in front of our decimal. So we're going to go 1, 2, 3, 4, 5, 6, 7. Is that what you guys count?
Yeah.
So we have 1.56013 times 10. Let's put 7 up there. And then you just have to decide once you get the correct number, is that going to be a positive 7 or a negative 7? Negative. Because remember, really small decimals means it's really, really tiny. So we want that negative. Okay? And the whole idea is that neither one's like the most compact way, but it's a little bit better than writing all these zeros out. All right? 3 and 4 are going to be the same idea, but now we're going to be moving it so it's behind 8, the 8s, all right? And then we're going to have a positive exponent, all right? How you can do this a little bit quicker is these are called periods when they're in chunks of 3. So we can go 3, 6, 9, 12, right? You can count 12 spots pretty quickly. So that's just 8.4 times 10 to the 12th. Once you get your exponent, ask yourself, should it stay positive or should it change to a negative?
Positive.
Positive because it's representing a really large number, all right? This is going to be the same idea. I can move it 3 periods. So I can just go 3, 6, 9. So I'll have 8.965 times 10 to the 9th. Should it stay positive or change to a negative? Stay positive, okay? So that's kind of how you do it, and also you do it the same way when we go from scientific notation to standard form. So standard notation, guys, is when they just give you numbers like you're used to seeing, and the scientific notations turn it into times 10 to some power, all right? So down here, 5 through 8, they're giving us in scientific notation, and we want to write it in standard form. So how I do this is I say, okay, I have 7.65. I'm kind of moving him out. And I need to move that decimal over 7 spots. The question is it going to be 7 spots to the left where I have to add a bunch of zeros in it and it's a really small decimal? Or am I going to move it 7 spots to the right and add a bunch of zeros behind it and make it a really large number? To the right. Why do we know that? Because we have that positive exponent, which means this should be a big, big number. So think about, okay, which direction do I need to move my decimal to keep it big? We're going to move it to the right. So we're just going to go 1, 2, 3, 4, 5, 6, 7, and put your decimal way back there. And 2 of the 7 spots were taken up with 2 numbers, right? But what do we have to fill the rest in with? 0. So we fill it in with 5 zeros, all right? So on the answer line, let's write it with like this commas in the right spot. So we'll have a comma there and a comma there. So we'll have 76,500,000. Is that what you guys get? Mm-hmm. And again, the whole idea here is 7.65 times 10 to the 7th is a more concise way, like if you're writing this in a report or something like that. All right, 2.42. Again, I'm going to pull 2.42 out here. And 10 to the negative 4th, I know I'm moving it 4 decimals, but which direction? To the left to make it a small decimal, or to the right to make it a bigger number?
Left.
To the left, because it's a negative, it means it needs to be a small decimal. So we'll go to the left 4. 1, 2, 3, 4. Notice when you move it to the left 4, that 2 took up 1 of the 4 spots, right? So what do we have to fill the rest in with? Zeros. So your final answer is 0.000242. 6.482, I'm going to bring him out to the side, and I'm going to realize that his exponent is a 6, but it's a positive 6, meaning I need this to be a big number. So if I start moving it to the left, I'm going to make it a small decimal, so I'm going to move it to the right 6 units. Realize that when I move it to the right 6 spaces, 3 of them are already taken up with 3 numbers, right? So that really leaves just 3 added blocks to the end. So we'll go 1, 2, 3, 4, 5, 6. So we'll just fill it in with 3 zeros. So you end up with 6,482,000. Does that look okay? Last but not least, 4.574. I'm going to bring him out here. Since I have an exponent of 6, I know I'm moving my decimal 6 spots, but since it's a negative, I want to make him smaller, so I need to move him to the left. Realize when you move him to the left 6 spots, 1 of those 6 spots is taken up by the 4, so you're going to have 5 zeros in front. So if you don't have to manually do that, that's fine. 1, 2, 3, 4, 5, 6. So you don't have to do that. If you're seeing what I'm talking, oh, there goes some lead. Oh, that's my lead for the pencil. I have more lead, but I'm not going to take the time to do it. Okay, so we'll put that there, and so we'll have 1, 2, 3, 4, 5 zeros in front. Look at that bad boy. So point 1, 2, 3, 4, 5, 4, 5, 7, 4. So that's a really small number. Are there any questions there? All right. So what I want you to do is on numbers 9 through 12, or just making sure we can do operations with it. And this is where I want to show you on your calculator. We can write it in scientific notation, but we also can type it in scientific notation. And I want you to see what that kind of looks like. So before we do it, it says, rewrite each number using scientific notation before performing the operation. Leave your answer in scientific notation form, okay? So this would be, let's see what we'd have to do. 1, 2, so that's 3, 6, 7, 8. So this is 3 times 10 to the 8th power, because I moved it 8 spots, and it's a big number, so I'm going to keep it positive, all right? That's a times there. And then this is times what? 1, 2, 3, 4, 5. Does that look right? 3 times 10 to the 5th, but I'm going to make that 5th negative because it was a really small decimal that I'm trying to represent. All right, so how do we write this in our calculator? You can actually type it exactly like this if you want, but typing times 10 caret 8, there's actually one button that we can hit that makes it all happen, and that's the EE button, okay? So what we're going to do on our calculator, go ahead and get it out. I'm going to show you. Right above your comma, so notice right here above our comma, we have that EE button. It's really weird because it's represented with EE, but then when you click it on your calculator, it's just one E. I don't know how they came up with that. So I'm going to do parentheses, 3, and then I'm going to hit second comma, and so that E comes up. Guys, that is our times 10 caret, okay? So now right behind that E, we can just write whatever power we want. So in this case, we want the 8th power. There he is. And then parentheses, 3, and then I'm going to hit second comma to get my E, and I'm going to put negative 5th power like that. And you hit enter. And you get 9,000. This is kind of interesting because it says, if you read the instructions, it says, write your answer in scientific notation. 9,000 is not that crazy big of a number, so like I wouldn't ever have you write 9,000 using scientific notation. But to get into the habit of it, let's just write that. What would that be? 9 times 10 to the 3rd. So this was 9,000, but we have to go 1, 2, 3 spots. So this is 9 times 10 to the 3rd. All right, number 10, guys, how do we write this? We'd have to move it over 1, 2, 3, 4 spots. Is that right? So this would be 1.2 times 10 to the 4th over 4 times 1, 2, 3, 10 to the negative 3rd. Does everybody agree with that notation? Is that okay? So we had to move it over 4 spots. It was a bigger number, so I kept my exponent positive 4. And then we had to move it over 1, 2, oh, it should be 4, right? Sorry. You guys get negative 4th there? Because then you go 1, 2, 3. I got to get behind the 4. So negative 4 power. Again, I had to move it 4 spots, but this time since it was representing a small decimal. When you do it on your calculator, I have I'm going to put in parentheses, 1.2 e to the 4th divided by 4e to the negative 4th. I hit enter. I get that. So it's still kind of a big number, but our calculator's not giving it to us in scientific notation. So let's write the answer out. So how many zeros are there behind there? 7, is that right?
7.
So that's 3, 1, 2, 3, 4, 5, 6, 7, which means we'd have to move it 1, 2, 3, 4, 5, 6, 7, right? So this is just 3 times 10 to the 7th if we want to write the answer like that. I'm trying to do one. Okay, this next one should show us our answer. So I want to show you that your calculator sometimes gives you the answers in scientific notation. So this one, guys, notice it's already in scientific notation here. So we're just going to type it in our calculator like that. So I'm going to do parentheses 2 second comma, so that's my e, to the negative 37th. So that's representing my first number, plus parentheses 4 second comma, that's my 10 to the negative 36th. And you hit enter. This is what I was talking about. So what you have to be careful is when you're working on My Math Lab, you might get some crazy numbers that are bigger than 1, but we're finding probability. And we just learned on Thursday, probability can't be bigger than 1. So I say, hint, hint, look at your back. You might have this e to whatever, meaning it's actually a pretty small number. So they just wanted us to do that in scientific notation form. So that's actually our answer, 10 to the negative 36. And this is going to be the same thing as well. He's going to be actually a really big number. Since he's already in scientific notation, I'm going to type him exactly like I see him. 3 second comma to the negative 18th. So this is 3 times 10 to the negative 18th. And then I'm going to do the caret button, caret to the negative 5th power. And when you do that, this is what I'm talking about. You on my math lab will get this answer, and you're going to want to put 4.1. I'm like, wait, what's the number 1 rule in probability? It can't be greater than 1 or 100%, correct? So if you get a number that looks like that, come back here and realize, oh, it's either a really, really small number, which in this case it will be because we're doing probability, or a really big number. So we'll just round to like 2 decimals. This will be 4.12 times 10 to the 87th.